All right, so in this section, we've been talking about how to find limits. And sometimes when we find the limit of a function, we get an answer that makes sense. We get 0, we get pi, we get 12, we get e squared. We may even get infinity. And all of those answers have meaning. Well, sometimes when we take a limit, we get an answer that doesn't make any sense, that's nonsense, that doesn't have meaning, and those are called indeterminate forms. And those are unacceptable answers. You can't stop if the solution to your limit is 0 over 0 or infinity over infinity. You have to keep going and manipulate and do some calculations so that you get an answer that has meaning. So I'm just going to go over briefly here the ways we're going to deal with different indeterminate forms, and then we're going to do some examples, which will be separate recordings, that'll show you how to employ all of these different methods. So the first one that we want to talk about is infinity over infinity, or 0 over 0. Now we already know how to deal with these because we can apply L'Hopital's rule directly to those limits. And we know how to do that. And we've done some examples, and we'll do some more examples. So those are straightforward. Those are taken care of. But what if instead of that, we get something raised to a power, like 0 to the 0 or 1 to the infinity? Those are both indeterminate forms, and they don't have meaning. They're nonsense, and we can't leave our answer that way when we're trying to evaluate a limit. Well, when we get into this situation, we have a trick that we can use. And one of the first things that we're going to remember is that e and the natural log are inverse operators. So if I take e to the natural log of x, the e and the natural log cancel each other out, and I'm just going to be left with x. So if I'm trying to find the limit as x goes to a of f of x, I can say that that's the same thing as finding the limit as x goes to a of e to the natural log of f of x. Which means that what I want to do in a situation like this is take my original function, that function that's giving me 0 to the 0 or 1 to the infinity, and instead of just finding the limit of f of x, I want to find the limit of the natural log of f of x. And that may involve using L'Hopital's rule, because hopefully when I try to evaluate this limit, I'm going to get an indeterminate form that I can apply L'Hopital's rule to. That's kind of the point of these manipulations and these tricks, is to come up with infinity over infinity or 0 over 0 and then apply L'Hopital's rule. So let's say that our limit down here as x goes to a of the natural log of f of x is equal to L. Well, that's going to be important if L is now a number, because that means I can go back up here and I can say that this is really e to the limit as x goes to a of the natural log of f of x, and I've already said that that's L, so this is going to be equal to e to the L. So that's what we do if we have 0 to the 0 or 1 to the infinity. But there are some other categories that we need to talk about. For instance, what if we had 0 times plus or minus infinity, and that was the indeterminate form that we got when we evaluated our limit? Well, when we do that, the best thing to do is to do a substitution. So we're going to substitute in for x, and we're going to say that x is equal to 1 over h. Everywhere we see x in our function, we're going to substitute in 1 over h. But that's not enough. You have to remember that you also need to change the limit. And that means that instead of x going to a, we're now going to have h going to 1 over a. And again, hopefully when you do that, you will either get a number, an answer that has meaning, or you're going to get an indeterminate form that you can use L'Hopital's rule with. And finally, our fourth category of indeterminate forms is infinity minus infinity. And when you get this situation, again, this doesn't have any meaning, and we need to keep going and keep evaluating and manipulating so that we can get an answer that has meaning, an answer that's a number. And what we want to do in this situation is to try to find a common denominator. And when we do that, then we're going to end up with a situation where we're going to have f of x over g of x, which probably means that now our indeterminate form will be 0 over 0 or infinity over infinity. And when we get that situation, we know that we can come up here and use L'Hopital's rule. So these are the four basic categories. We will have examples that go through all of these and show you how to use them.